Safe Software is pleased to present the 2009 FME International User Conference. This session is presented by Wes Harden and James Katz of Burns McDonnell. Wes is the One-Touch PM Product Manager and has 20 years of combined experience in engineering and information management. James is an information management specialist and has over 9 years of experience in GIS.
Thanks. I'm Wes Harden, and this is Jamie Katz. Last year we kind of presented the first, I'd call it the beta version of this. Since then we've adopted some new technologies, and we're not really going to go through a lot of the stuff we covered last year. We're just going to kind of show some of the stuff that is new that people that were here last year didn't see. If you have any questions about some of the reasons we did other layers and things like that, feel free to catch me after the session or anytime you see me. Just a brief intro of Burns McDonnell. I'll try to keep it as brief as possible. We're primarily an engineering firm, about 3,000 employees in Kansas City, Missouri. We have a division called BTS, which is about 100 people strong, which we belong to. Here's kind of our headquarters. 100% employee-owned, full service, and EPC contractors. Probably our biggest projects are huge construction projects, usually in the range of $1 billion or more. You can see down here, we're in energy, transmission and distribution, environmental studies, construction design build. For this project, we developed, to manage these large linear projects, we developed what we call One-Touch PM, which in a nutshell is a geospatial dashboard used to organize all the project's information and make it easily accessible and useful. And if you know Google's mission, that's a lot of their mission. They're just dealing with the world. We're just trying to deal with the project and make this be the one-stop shop for construction managers, field supervisors, everybody from the clerks to the CEOs is where they go for their information on these projects. Currently, we're managing about $15 billion worth of construction projects across the country, all the way from California to Maine. Probably at this point there's about 300 users logged into this same system. We are running live. I've copied a few things to my places, but for the most part we're going to show live data, so keep that in mind if there's any glitches. There's people in the Sierra Nevada mountains using this. There's people in the backwoods of Maine all logging into the same system right now. First area we're going to talk about is kind of probably the biggest use of this, and this is managing right-of-way. These large projects have a lot of issues with landowners. They're going through a lot of backyards. Nobody wants a construction pole in their backyard or a transmission tower in their backyard. And here's an example of one of the projects we're doing right here. This is Greater Springfield Reliability Project in Maine and Connecticut. These are just different lines of existing towers. And I'm going to turn it over to Jamie at this point and kind of show you some of the data we've brought over and how we're leveraging the systems they already have in place. One of the things I want to say is we don't really convert a lot of data. We actually try to integrate into the system itself. So instead of copying data over from the source systems, we try to create links into the source systems, thus leveraging the securities of the source system and not having to copy attachments over or anything like that, and not getting into a lot of issues with regulations. These projects are very highly visible, and there's a lot of laws and stuff about letting people see data that they're not supposed to see. We've kind of monkeyed up some of the data and what we're showing, so we should be good. But it's key to understand that we don't convert a lot of data. We just try to link into the existing systems.
Right. As Wes mentioned, the acquisition portion of these projects is a big deal. A lot of real estate, lots of money involved in the real estate acquisition portions for these big linear projects. We're looking at in U.S. and I think we're at 500 or so square miles of real estate acquisition that's abutting the right-of-way. So in order to manage that, we have obviously a parcel database, and the parcels have been digitized around the right-of-way. The real estate group within our company tends to use a database called Contract Manager. which is also tied to the schedule and the budget. And we've linked our parcel database through KML, through FME. It's on an Oracle platform, and it's all Java, but we're actually inheriting their security permissions and parameters and coming through. And so, as Wes just showed you, he clicked on a link in our parcel data set, and what we've essentially created is a spatial search for this database, and it will bring up the information associated with that parcel. So within the KML, we have a hyperlink that's going directly into the database. In Contract Manager is where they store all the information associated with that parcel, so the real estate acquisition team will load attachments, email files, information about that parcel, landowner information. So Wes just clicked on an attachment, which will be just a PDF file that will pop up and give you, we can tie anything really to this system. We can associate deeds and PDFs, text files, anything that you want. We can attach it to this through this mechanism.
So really, within a couple clicks, you can get to anywhere, any information about the project. And that's why we call it one touch. Is just a couple touches. You can get as detailed or as general as you want. Also, what they're using the system for is to deal with the community relations aspect, which is a big part of these projects. There's a lot of eyeballs on this. There's a lot of opposition. So we're managing the community relationship portion with that, and these are encroachments. So as you can see, it gives you a little bit of detail at the KML level. You've got an encroachment, you have a fence line, and then if you want to subsequently search deeper into the database, you can click on the hyperlink and it will go into Contract Manager and associate all the data with that. And so you can look at this parcel and they have quite a number of issues. There's 7 issues there. So the real estate folks really like this because they can search to an area, they see everything that's associated with that parcel, the community relations aspect, they know exactly what the parcel information associated with it is, and they can subsequently manage that portion of the project. Yeah, this is a good example of how the power of this tool is, because there's so many issues here. The way they used to handle it is they'd print out sheets of paper that listed all this out tabularly, give it to the construction manager, and it may say, hey, don't cut down my tree, or call me before you're here, and they made a lot of mistakes in the field. Now the guys all have laptops in the field. This data, most of it's no more than a minute old. Once there's a change that happens in Expedition, it kicks off a translation which updates the KML, and so they should have the latest and greatest data. And it reduced that communication problem of going onto a property and not knowing what was going on. Now they go onto the property and know everything that's going on. Next thing we're going to kind of show is overhead, which is kind of our placing of Colada models.
I think one thing to emphasize here is that one of the cool things about using the system is that we're serving up about 1 terabyte of information, and people are able to access this with their laptops out in the field, remote. So it's pretty cool. Big far cry from where we were at just a couple years ago. So people like that aspect as well.
So here you can see the overhead status, and we actually bring in the engineering design drawings that are in a PLS CAD format. We export them out to a KMZ with using their format, their exporter. Problem with that, the KMZs are so large because they're using wireframes and they're trying to do it in the regular KML framework and not in the model tags. As you know, at this point, maybe in the new version they have it, but in the version we're using, we can't write out models or place models with the standard FME writer. So we kind of created a little shutdown script that replaces some things and is able to place these models for us. What this does for us is if we zoom in, whereas before we brought this in as a bunch of KML polygons and points, now we're actually able to bring in the full Colada model, textured as stainless steel. If it was a wood pole, it would look like a wood pole. This is accurate within an inch on height. The other neat thing about it is it's relative to ground. So even though this pole, this construction or this design was done with a different terrain model than what we have in Google Earth. Now, we can bring a terrain model into Google Earth, but we thought, well, why don't we just make this relative to ground, and then we don't have to worry about it. We can actually turn off the terrain, which for guys out in a truck with low bandwidth, they may not be able to pull up the terrain anyway. So this way we can turn the terrain off and still have a 3D model that's relative to ground. Just a quick show of what's actually going on here. It's very, very simple, actually. Like I said, we're not actually writing out the Colada models with FME. We're placing the Colada models. So we go and create a library of models that are different transmission poles, and then we identify those by the type. And then we place those based on the height, and then if it's a shorter pole but the same design, we basically shove it under the ground and it goes in. So what we're able to do is serve up a huge amount of data with only maybe 15 or 20 different pole designs, and we're only loading in that Colada model over and over and over again. So from before, when we brought this 100-mile line in and it was pushing a megabyte, now we're probably about 100 kilobytes, and we're able to render it, show texture and everything else. That actually works out pretty well. And all we're doing is creating our own model tag, storing it in the KML snippet tag, and then we have a shutdown script that goes in after those KMZs are created and replaces the snippet with the model tag, and that's how we're able to replace it. So we're able to take, once we have our library of models, we're able to take any design that's been done and very quickly place it, because they're all, with PLS-CAD, everything's done at engineering grade. So we're able to create very high accuracy models in here, and hundreds and hundreds of miles of lines without shutting down the system. The next thing we've really started doing a lot of is charting. And we see this for us as where we're going to probably leverage FME server the most. I'll give you an example of some of the charting we've done so far that are being used in the field. So this is one they use in Oklahoma, and they want to know how their acquisition's going. And before, they had to go to the database and run a custom query and figure it all out. Now they just come in the morning, click on this link, and it gives them an acquisition status report on the fly. And that's up to date because that's pulling from the latest data. So it's all up to date. They don't have to go outside of this to go find that data. They don't have to go ask for a custom query, things like that. I'm going to pull up that translation and let Jamie explain what's going on.
Okay, so this one is based on Fusion charting service. I don't know if anybody's played with that, but it's a Flash XML charting service, and it just returns. We are using the XQuerier, which is kind of interesting because playing around with the XML files is a little bit tedious sometimes. The schemas are a little bit difficult to deal with. So I'm not going to go too deeply into it, but we're doing a little manipulation here to create the X and Y axes, and we're also defining some of the values of those charting aspects.
We are simply grabbing the view, like I said, when it sends the URL with the translation, Google Earth automatically appends the bounding box of the view. We're using the image or the data streamer service and parsing those bounding box out of that stream and creating a bounding box, a real bounding box, clipping the data, and then sending the results to a URL that we use the image fetcher and brings back a PNG, and then we output that to a image overlay. That's pretty much that. The last thing I wanted to show you is, we talk about being in 3D. We're kind of trying to get ourselves in 4D. I think if you were at our session yesterday, you saw some of the animations we were doing with South Florida. Here's one we're trying to use for, we're getting a lot of requests to help out with wind farms. And so we're starting to develop systems that help manage wind farm development. And here's kind of the demo of what that looks like. So again, we've created this with FME. We've created our models. And we basically created the blades as separate models. And this is the engineering design. This is the actual design that they used in the field. And we just created basically the blades as a separate model, used FME to rotate it, made several copies that are all time-stamped, and now we're running a animation showing it. And so we actually are going to work to try to tie this into real-time monitoring, so you could go out and look at this and see and look at real-time data and say, okay, how much megawatts am I producing from this turbine? Why is this one going slower? Things like that is where we're heading with this. I think that's about it. Is there any, we'll open up for questions. Yes?
Yes, I was curious about what you could do with standard Google Earth. Is this Google Earth Pro, right?
This is actually Google Earth Enterprise. We're one of only a couple engineering firms that are able to, that have the Google Earth Enterprise platform. And so if you notice, the world looks a little bit different. Let me turn off some things or we're going to crash. The world's a little different than what you would see with the standard Google Earth. So we're actually serving up our own world. This isn't connected to Google at all. It's actually served out of servers in Olathe, Kansas. We create our world. These lines, they typically go and fly the line. So that's why you'll see for each of our projects, if we go back.
So could I actually view your data in standard Google Earth though if I wanted to? Can you serve that out to
It's all KML based, so yes, you could. Now the difference is, if we were to give it to you, you'd end up in my places. We're serving it up under a secure environment, under layers, so you can't go. If we could give you the Google Earth client and a password, you could see it through that way. Or if there's a piece of it you wanted a piece of that you didn't want to have to buy Google Earth Enterprise, then we would just send that to you as a KML. All this is KML based, except for the imagery, roads, all that's been fused into the world. But you can see, this is all our custom imagery. One of the problems we had with Google Earth Pro is they're not very accurate and they tend to change imagery on you without telling you. So when you're dealing with encroachments and engineering designs and things like that, people are making decisions that may impact the project, and we didn't want them to make a decision off imagery we weren't comfortable was accurate enough. So we do all our controls and the imagery. We bring it in. All these projects are $1 billion and up, so they fly the line ahead of time. So we have usually 6-inch resolution. I think up in Maine we have 3-inch resolution, and we bring that in the whole quarter in and make sure it meets all our control points and matches up and everything's good to go. Yeah?
Are you using animation to show progress on the project over time as well?
That's what we're working on. We'd like to try to timestamp, like maybe at the end of the month, here's our set of data. And really by next year, we want to have a full fourth dimension where you can actually pull back the time. Because like I said, a lot of these projects they're so big and they're so complex. And somebody's always calling and saying, oh, you screwed up my driveway or you did this. And so they're always having audits and having to go back. And we'd really like to be able to say, okay, what was it at the end of June 2008? Let's slide it back. Here's where we are. Thanks.